In this lab, you will be given a piece of magnesium that you will react with hydrochloric acid. You won't be using a balance to find the mass of the magnesium in this reaction, but by collecting the hydrogen gas produced in the lab and doing some calculations, you must determine the mass of the piece of the magnesium that you were given. Set up your lab notebook with the title of the lab and write down the purpose. The purpose is to experimentally determine the mass of a piece of magnesium by reacting the magnesium with hydrochloric acid and using the ideal gas law to determine your unknown mass. Below the purpose, write the correct balanced chemical equation for the single replacement reaction between solid magnesium metal and aqueous hydrochloric acid. This isn't in the instructions, but the first thing you need to do in your procedure is to measure the length of your piece of magnesium. And we won't know until the day of the lab what that length should be because it depends on the atmospheric pressure. But I'll let you know the day of the lab what that length should be. Wrap and tie your piece of magnesium metal in a long strip of copper metal. Make sure that the magnesium is securely trapped in the little loop or cage of the copper, but that it has some space around the magnesium so that the hydrochloric acid could get to it. You need to leave about a 2-inch tail of copper metal not tied up in the magnesium. And that'll go into the stopper, but those are already set up for you. Fill a 1-liter beaker with tap water. The water needs to be about an inch from the top of the beaker. At the supply station, you're going to pour about 10 milliliters of hydrochloric acid into your gas collection tube. This doesn't have to be perfectly exact, but you need to be around the 10 milliliter mark. Then very slowly fill the gas collection tube the rest of the way up with distilled water. Pour the water very slowly so as not to mix it too much with the acid in the bottom of the tube. It will mix up some, but we don't want it to mix very much. If you have bubbles sticking to the sides of the tube, you can kind of tap the tube with your finger to dislodge the bubbles. Then lower the magnesium in the little copper loop down inside of the tube. You're going to use a stopper to do that. Hold your finger over the hole in the stopper. Invert the tube and lower it down into the water into your 1-liter beaker. Have your lab partner clamp the tube in place and remove your hands. You can kind of just let the gas tube set along the clamp. You don't actually have to completely clamp it in. You're going to let the apparatus stand for about 5 minutes after the bubbling has stopped and all the magnesium has reacted. You kind of want to tap the sides to dislodge any bubbles that might be in there. Disconnect the tube from the clamp and move the tube up or down until the level of water in the tube is the same as the level of water outside the tube. Read the volume of gas that you collected. Read and record the volume as accurately as you can. Clean up by pouring the contents of the tube down the sink and rinsing your glassware. You need to leave the lab cleaner than you found it. The stoppers we will keep for next year. Now you will need a ruler to make your data table. And it's going to take up probably at least half a page. So if you need to turn the page, go ahead and do that. You're going to make two separate data tables. They're on the back of your lab sheet. And I want you to separate them out. The first one called data. Go ahead and pause the video and take a minute to put that in your lab notebook. The other table we're going to call data calculations, which is a little strange, but they're calculations that involve converting some units for your data. We're going to get the pressure today from our barometer in the geosciences room. But if you're ever interested, you can just look up the pressure online on a weather website, and it will tell you the pressure in inches of mercury, which we usually have to convert for the kind of stuff we're doing.